Hello, everyone, and welcome to session 4, which is also the last session of the Into the Modern GitHub series that we've been running throughout March. And today I have Sanjin and Magnus with me. But before we start, I would just like to say a quick word about Microsoft Code of Conduct. We are all here to learn, so just please be welcoming and respectful to all points of views and be kind and considerate to everyone watching. So yeah, now let's talk about elevating security with GitHub Advanced Security. And today's session is going to be presented by Sanjin Medic. Hi, Sanjin. How are you today?
Hello. Hello, I'm very well. Sunny weather, feeling great, and happy to be here and talk a little bit about GitHub Advanced Security.
Yes, we're super excited about it. And of course, we have Magnus, the famous Magnus we have here with us today. He's been with us for the past 3 episodes as well. And Magnus is going to be supporting on the chat. So just go ahead and ask questions. He's excited to answer them.
Yes,
Magnus, welcome back.
thank you very much.
So I think it's enough of me now. I will hand the word over to you guys or to you, Sanjin, and let's get rocking. Let me just add your screen here. And yeah, I'm going to be in the backside, in the back end if I'm needed. I see you in an hour.
Yes, thank you so much, Erika. All right, so my name is Sanja Miric. I'm head of development of Solidify. I'm working also as a DevSecOps specialist, and I'm also over chapter leader for Stockholm chapter. Love security, and my mission is to improve security in application development. Let's talk about what we're going to cover today. We're going to talk about the state of security today. Then we're going to talk about supply chain, and at the end, we're going to talk about securing the code. So the state of security today, as we have seen, there is a lot of things happening last years. There is an increased number of threats. We see also a new number of threats, destructive ones, not only economic interests in line. So there is a need for improvement. And if you look how we develop software today, we are using a lot of packages, and this is completely normal. This is how we should work. We are reusing code. This is a very good thing to do. However, this means that we in our solutions usually have between 80 and 90% of the code which is developed by somebody else. So no real knowledge about the quality and the state of that code. And if we look even further, we see that employee error is one of the number one problems in the code. So exposing access token, creating unsafe code, those are normal things, and those are things that happen. And we need to find a way to protect ourselves from it. But our approach until now has not been perfect. So if you look at the state of AppSec, as you can see in the chart here, we have more and more code, perfectly normal. We're developing more features. There is code absolutely everywhere right now. But we are also getting then the same number of vulnerabilities. It's a linear increase. And based on that, we are investing billions of dollars into securing software development. I would say our expectation, or at least my expectation, is to have a bit better results. And the latest statistics kind of we can see that 85% of applications still contain insecure code. So we're not getting better, but investing a lot in security. And at the same time, the flaws that we are seeing in our application There are coding flaws, and these are number one vector for attacks. So it's not infrastructure, it's mostly flaws in applications that attackers are focusing on. And this is a bit hard to solve. There is a knowledge gap, and honestly, we require a lot from developers. They need to understand cloud development right now. They need to understand scaling. They need to understand handling um, uh, zoning as well, and modern development. So there is a lot of requirements on them, and if we put DevOps in the picture, it gets even harder. If you look at the companies, on every 100 developers, we have one security specialist. And these are people who are trained into like security, understand the work and so on. And we can't really require everyone to have this deep knowledge. But it is a lack. 1 to 100 means that there is a limited number of things this single person can do. And if we look from what developers, the feedback from developer side, they are arguing that the lack of knowledge is the main problem here. So these are the things that we need to address somehow. If we look at leaking secrets or credentials, this is another issue that we have, and seeing on the metrics here, we have from January 2019 to September 2022, 65% increase of leaked secrets tokens in repository. And these numbers, in my experience, if we look at certain companies, these numbers are even low, I would say. So there is a lot to do. So how can we solve this? We already had tools previously that scanned the code and so on and so forth, but they were so long from developers. And this is where GitHub Advanced Security comes into the picture. We have this solution that is developer first, so it's created for developers. It's native to the way how developers work on the daily basis. So it's integrated in GitHub in a way that no other tools is. And it's really automated. So there are some features that you can get that increase your security without you needing to take action. Well, you need to approve pull requests, but a lot of things are already prepared for you. So we're talking about GitHub Advanced Security. And a lot of features that we talk about today, they are available on open source public repositories, and they are also available to companies that purchase the GitHub Advanced Security licensing. So what is included, what we have that increase security? So let's start with supply chain. We have dependency graph, which is the first step of actually understanding your security, analyzing security in your software, knowing which packages are used and how many they are, and how much exposure do you have to external code. So the first thing is dependency graph. The next thing we talk about is security alerts and updates. So now when we have graph, what we can get from GitHub Advanced Security, or Dependabot in this case, is a list of vulnerabilities, and you get alerts on the vulnerabilities that are found in packages. On those things, you can also turn on automatic pull requests. So there is automatic updates that Dependabot can do that creates pull requests and solves those vulnerabilities that you're notified of. So this is a huge thing. This thing can be also turned on for automatically updating your versions, regardless of vulnerabilities or not. And this is a great way for you to keep your applications away from becoming legacy too early. The last thing is dependency review, which is a powerful action that we can put in our pipeline that will scan the changes that you do to dependencies, and it can block pull request or it can allow it. The good thing with this is also it can also scan for licensing, which licenses are you including in your project. Very interesting and very good thing, especially if you are if you have a problem with using licenses that are not used, and dependencies, of course. Next thing, securing the code. There are two parts. First one is secret scanning, and this is, as name suggests, it scans your commits or your pushes to GitHub, and it looks for APIs to tokens to something that is secret. And it will go through history for all your commits, and this is something that you can add your own custom things, custom secrets to. This works on regex, and in some cases you can get on public repositories you can get the verification as well. For code scanning part, this is something that can be done as a static analysis for every Git push. And for that, we are using a tool called CodeQL, which is a really competent and potent tool that can do a lot of great things and enables you to scan the code in a really nice way. And of course, with everything like GitHub, there is a strong community that can help you with creating CodeQL queries and so on. But I will touch into that a little bit later. On the development lifecycle side, we have branch protection rules. You can put on rules what you enforce certain requirements for pushing branches or creating branches, who are allowed to do what. And then there is also a feature that you can have commit signing, which enforces requirements that all commits are signed. Let's go further and talk about supply chain. Because we use so many packages, we are exposing our code to actually vulnerabilities somebody else can include, or the mistakes somebody else made. And of course, this can happen anytime, any time of the day, even when we are not actively working with the code. So there are examples that you have perfectly fine code, totally updated, and you are coming into a maintenance period, and you can see the number of vulnerabilities increase over time, even if you have something that was perfectly fine in before. So this is something that needs to be managed, and this is the reality of software development today. With Dependabot, this reduces the manual overhead needed from developers, and this is something that Dependabot can help you with. And when we talk about the Dependabot, there are it's a tool that will automatically raise alerts. It will automatically open pull requests if you wanted to. There is a setting. I will show you how you can do that. And it will notify appropriate people about what is happening, what vulnerabilities, or what alerts do we get. There is also another really nice feature, which is a compatibility score, which kind of guides us of how secure this update is. And there are two types of Dependabot updates. The first one is security, so securing the code, so fixing vulnerability threats. And the second, as mentioned before, is versioning, which will help you create solutions which are, they will not become legacy too early. And the last thing that we have talked about is dependency review, the famous action. It will trigger and scan all changes to like added, remove, or updated dependency. It will list release dates, popularity, and vulnerability info, so you get a bit knowledge of get some metrics about how well maintained a package is. And it will also show the licensing as well. Now, this review, this action can also block pull requests. So if you are increasing, so if you have vulnerability of certain criticality, or if you have licensing requirement for your code, this can also help you out and block the code. Enough talking. So let's go and demo Dependabot. I have prepared a repository here in our solidified demo organization. Now this is a demo organization and we have a lot of insecure code. This is by design, so no worries about that. Now this is a pretty straightforward application. We have a backend and frontend in the same repository, so it's monorepo. We have Terraform scripts for creating infrastructure in both AWS and Azure. And then we have a backend which is container based. So it's a little bit of everything, and this is a perfect way for us to actually showcase all the features of Dependabot. There are a couple of things we need to do. The first is turn some features on, and we do this under settings. So if you go to repository and settings and go to code security and analysis, and right here we have a lot of features that we can turn on. Now in our organization, some of the features are enabled by default. In your case, you might need to do this manually. So the first thing that we're going to talk about is dependency graph, and you can enable it, and of course you can disable it. But this is the requirement for some of the feature later on. So if I try to disable this, I will get message that Dependabot alerts and Dependabot security updates will be disabled as well. So how do I understand dependency graph? If I go back to my repositories, there is a tab called Insights over here. And if I click on it, and on the menu on the left, I have dependency graph here. If I click on that, I will see all my dependencies, and I will see which manifest files have been scanned. So I have a backend C# project, it's .NET. I see that I have one known vulnerability. This is because I have this feature turned on. I can see that on front end, I have a lot of dependency, and this is pretty typical for a web project. And I have I have vulnerabilities here as well. And one thing what I can do is if I do something like Webpack, I can go in and start drilling down into seeing dependencies and what packages my dependencies are dependent on. And this can be really deep chain of different dependencies and what I have in my code. So as you can see, there is a lot of places where developers can make mistakes. So this is first step. So for me as a developer and an architect, this is a really good way for me to understand the threat posture. So how exposed I am to certain external threats, and to just understand it and act on it. Next feature that we are talking about is Dependabot automatic updates. So the same thing here, repository, settings, code security and analysis, and we have Dependabot alerts. So this is enabled, which means that I will get alerts in the insights, but also on the security. And I have automatically updated security updates as well. So this is those things I usually turned on at the same time. But you can fine-tune it and turn one, not the other. For alerts, we have seen that we see that on dependency graph. So we see which packages are vulnerable, and we can see the CVE for that. We can see severity level. We see which package and so on. And another thing that we have is this security tab. And under security tab, I can see that I have 5 security alerts. And on the menu on the left, I see there are 5 Dependabot alerts. So this is alerting, and I can see all the alerts I have. I can read information about them. I can see that this is a vulnerability in Webpack. It affects all versions between 5 and 5.7.6, and it's patched in version 5.7.6. So I need to update my dependency to 5.7.6.0 to fix this error. I can see some data, which severity, and some metrics here as well. And also I can some EDs if there are. So there is a lot I can read about this dependency. If you look at the other ones as well, we can see a bit more data when we have impact, we have mitigation, we have details about the problem, and so on. So everything is compressed and everything is available, and it's really easy for me to understand what the problem is and what I need to do. Because I have turned automatic updates on, I can see that I have a couple of pull requests, and you can see here as well. So I have 3 pull requests, and they are created by Dependabot. So for every vulnerability that Dependabot can fix for me, it has created a pull request. So let's go for this JSON 5 and open this one. And we can see it wants to bump my code from 1.1 to 1.2, which is a minor change because we are doing this based on semantic versioning as well, of course. So 1.1 1.2, which means that it's a minor change. But of course, I have a change log here, so I can see what has been done, and I can take a decision if I want to merge this or not. I mentioned compatibility score, and this is a great feature. So this is based on public repository and how well the CI/CD pipelines have worked after this update. So this is quite high score, which means that I can feel pretty confident that this change won't mess up my code. I should test it, of course, but this is a great way to get you some confidence. So in this case, let's say I have tested it and I'm happy with it. So what I can do is I can confirm this merge. Now this is merged, and if I go back to security, I see that I have 3 Dependabot errors. 2 were the same error. There's 2 vulnerabilities in the same package. One thing you will see and you will work a lot with is Dependabot alerts, that there are some open and there are some closed ones. This means that the closed vulnerabilities that I have, I will be able to see what has been done. And if I go ahead and go back to the open ones, and if I see something that it's not relevant for me, I can actually choose to dismiss this alert. So in cases you don't have a ability to create this, there is no bandwidth, you feel that the risk is tolerable, you can actually dismiss this error. So let's say I don't have bandwidth to fix this, I want to fix this later, I can select the reason, write a comment for it, and press dismiss. As you can see here, there's a log. It logs everything I do here. I can see here that this vulnerability or alert is now dismissed. Good thing is if I go back to Dependabot, we have two open ones, and now we have 3 closed ones. So if I go to close one, I can see the one I have closed as dismissed. I can always reopen dismissed alerts. So this is a great feature, which means that I can choose to close something temporarily and then go back and reopen it. Be careful though. Don't close things and forget about them. If you choose to dismiss errors, you should have a reason to it. Don't do it as a way to just remove problems. Of course, we can do filtering for which manifest files, severity levels, ecosystems, and so on. So there is a lot of things we can filter on, and of course, this can help us manage this list if it's long. I've seen the lists like this that are very, very long, a lot of vulnerable dependencies, and this happens usually on legacy applications. Let's go to the next part, and next part is version updates. So I will enable this. Now for version update to work, I need to actually create a YAML file called Dependabot YAML. And I get the boilerplate for this. And of course, I get a link to a documentation. So I got the link, and if I go there, I can actually read a lot about Dependabot YAML file. Really nice description, what I can hear, what configurations I can do, and further down there are some examples on configurations. So what can you configure? How can you improve this so it fits your workflow? Really nice documentation for the developers with examples how to turn on this feature and what you can do here. Of course, let's configure. So the first thing I need to do here is point out the package ecosystem. And this can be NPM, can be Java, Python, C#, and many others, Docker as well. I need to enter directory, and I need to have a schedule ready. Now, because my application doesn't have anything in root, I will get error for this. So what I need to do is I need to make sure that my file points to correct the directories and has correct package ecosystem configured. So we have Docker here, as mentioned, we have Terraform, we have NuGet for backend and NPM for frontend. And I selected Introvert to be scanned daily. When I'm done, I can commit this. And after initial scan, I will start to get new pull requests that will update my manifest files with the new versions. And this is regardless if there are vulnerabilities in them or not. It's really important that we have correct configuration here. So it's really important that we point to correct directory. Otherwise, this won't work. And how you can verify that this actually works, if you can do that by going to Insights, Dependency Graph again, and in this case there is a Dependabot subtab, and if I go there, I can see dependencies that are configured, or what manifest files have been found. If you configure this, if you misconfigure this, you will see it here. So you will see error if Dependabot cannot find a manifest file. But right now we have seen that 2 has been checked, and the other ones are completing right now. And what we can see here is number of pull requests has increased. So this is something that we are getting help, right? So we have this testing library of React, which has been automatically updated for 13.4 to 14. Now this is a major bump. So in this case, I would like to be more careful. So I will go through release notes, see what has been done, and I can see there is a breaking change, which means that I can actually go in and understand how this will impact my code. What I can see that in most of the cases, this wasn't a big issue for others. And I can take decision of like if I want to merge this pull request or not. Let's say that this breaking change here is something that will affect me. So I have breaking change here. In this case, I would like to tell Dependabot that, all right, turn this off. Don't mention this version again. I will update it in the next version. So what I can say to Dependabot is there are some instructions here. So I can communicate with Dependabot and give Dependabot instruction on what to do. So cancel, merge, reopen, close, or I can just say something like this: ignore this minor version, but do tell me when new version comes. So I want to do this. So I'll just copy this and I will write the comment. Now what will happen is Dependabot will automatically close this. It will also write a comment. And you can see it's a sad Dependabot. But this helps me handling the number of pull requests, and it helps me handling this load that I get. There is also configuration that I can do which limits number of pull requests open per package ecosystem. So in some cases you want to configure it that way. So this is about Dependabot. I wanted to emphasize a little bit about this because there is a lot good things that you can do with Dependabot. So it does improve security a lot. Let's go back to the slides. So next part, what we uncover is secret scanning. Secrets and handling secrets is one of the core things we do in our application. So we have a lot of keys, we have connection strings, we have a lot of dependencies in our code, and we need to manage those in a good way. Now, in many organizations, there are policies, there are ways how to handle secrets. There are things in GitHub you can use. There are cloud services you can use. There's different parts, different products that you can utilize for that. Now, even we have this mistakes will happen. I mean, maybe you are do some proof of concepts on a local machine, and you're just inputting code in line just to get it to work, and you forget about it and you commit it. Now, what happens with secret scanning is that it will actually go through secrets, and it will go to history as well, and it will see if this is something that is real secret. So if this is something that it's configured, if it's secret, it can actually block your pull requests, or it just can put a vulnerability and warn you for it. And this is a bit, there is a bit of difference how this works between public repositories and private ones. So there is a list of partners that have been they have collaborated with GitHub to creating regexes for the secrets. So false positive rates for the community-based secrets is quite low. So the ones that secret scanning partners that GitHub is working with. So low false positive rate. However, if you have your own secret patterns that you want to search for, you can do that as well. Right out of the box, there is a large number of secrets that are included. And these are some of them. You can see there's Azure, there are multiple Azure tokens you can search for. It's AVS, there's NPM, Postman, Slack, and so on and so forth. So there's quite a lot of keys that we usually use. And for full list, you can read about that on the GitHub docs. So you can see supported secret, and if I can go through lists, so there's quite a lot. And you can see the difference here between the internal version and the public version, what's happening. So I mentioned there is a difference how this is handled. If you look at the public version, what we want to do is we want to scan for secrets. So what happens when you do a push of changes, commit or push, is that GitHub will run regexes, the patterns, and will check if this is a secret pattern or not. And if it finds that this is a pattern that is similar to secret pattern, what it will do, it will verify partners, or it will verify against the endpoint if this is a real match or not. And once that is done, it can revoke a secret, it can send alert, or it can do both of the things as well, or it can choose not to do anything. It's up to actually partner and GitHub to collaborate on this one. This flow is different if you are working with private repositories. So with private repositories, we have a change here. So for private secrets, you don't send anything out to public to partners, and this is to protect your secrets. Maybe you want to have them there, maybe you have something that is important and you don't want to leak it to somebody else. So this is a security measure for the private ones. For the public ones, of course, because you have committed it, it is already public. You need to actually change this, because this can be something that can cause you damage. I also mentioned that you can do custom patterns. So there is a long list of already created patterns that you will get out of the box. But if you want, there is a possibility for you to create own patterns. So this is something I will cover a bit on demo. This can be done on organizational level as well. So you can create up to 500 patterns on organizational level, and up to 100 on repository level. So there's a lot of custom patterns you can do, and here you can actually choose your strategy. You can choose to be very specific with your patterns to create a less false positive, or you can create patterns that are a bit broader, but they will, of course, you will get some false positives from them. So this depends on your strategy. How do you want to search for patterns in your organization? Another thing that I mentioned is push protections. There is a way for us to actually block pushes or block commits to our repository if it contains secrets. There is, of course, way that we can bypass this. So once you get this error, you can have a link that you can dismiss and this alert, and you get a window of something like 12 minutes or so to actually complete pull request or push after you have disabled it. If you wait a bit longer, then you need to redo the process. And this can be enabled on both organizational level, but also on repository level. So let's talk about. So let's have a demo about it. Once again, I go to my repository, to settings, to code security and analysis, and right now I need to turn on GitHub Advanced Security. I'll get some warning about how much. This is because it's a private repository. I will get information on how many seats I'm using. And then I can configure code scanning and secret scanning here. So right now, the secret scanning is already enabled, and I can see that push protection is enabled. So let's disable this just for demo. Another thing I can do is I can create a new pattern. And one thing that I start with is put in some pattern name. I will put in a pattern example for a pattern. So let's do something really, really simple. So 0 to 9, and I want to have it 4 times. So this is my secret format. What I can do is I have a possibility to add more options. So patterns for before secrets, after secrets, and so on. And this is something that I can chain. So I can chain additional match requirements as much as I want. I don't need that, and after secret and before secret, I use everything, so it's not valid for me. So the next thing, what I need to do is input a test string. 1, 2, 3, no matches. This is good, and I can proceed from here, or I can actually make sure that I get the match. I'm happy with this. And right now, what I will do is I will do a dry run. So this is queued, but because my application is quite small, this will go quite fast. So if I reload, I can see that I have a pattern published. So I have no matches found. It's not published yet. And this is where you need to be careful. Once I press publish, this will be active. And this will start to scanning all commits. Especially if you do this on an organization level, you will get some results. All right. So what I will do now, I will change in README file so I can trigger this vulnerability. And what I will see now, this is the pattern I'm searching for. So, and under security, I will get some secret scanning alert. And of course, it will show me where. Quite easy. And one thing that I need to do is actually solve this. So for you guys, you need to have process in place. You need to know how to rotate the tasks and so on. Of course, you can see here that I'm getting the alerts that a possible valid secret is detected. Exactly what I want. So let's continue. There is, of course, there's so much to all those things. There is a possibility for us to exempt certain patterns. We can also configure this in a certain ways, but there's quite a lot how to affect the flow of this. Let's talk about code scanning. Now, for code scanning, we want to check our code and see if there are significant problems with it based on static code analysis. And for this, we're using a CodeQL. And CodeQL is a very good tool. Let me talk about it. I will mention capabilities and how it works a bit later. With code scanning, you will get the result in your developer workflow. So as everything in GitHub Advanced Security, it's there for you. It's accessible. It's where you actually use your code. And this is where we have a possibility to include even other tools. So GitHub, CodeQL will have you vulnerabilities, will have alerts in the same way presented where your code is. But if your tools have a possibility, if your tools have if you have other tools that can export SARI format, you can include them as well. So the CodeQL, it's a tool that has been in development for 13 years with a quite large team, and it's a well-known product, and it works really good. So it creates a database that you can use to actually see which vulnerabilities you have. really configurable, and you can create your own queries. You can use the queries that are there out of the box by GitHub, and you can of course use the community-based queries as well. There is possibility also to include others. I will showcase that as well. So as long as partners use SARI format, you can actually make sure that their alerts as well are shown into the GitHub Advanced Security. So let's go to demo even here. So GitHub Advanced Security. So this is my repository. I will go to settings, code security and analysis, and right here I can actually choose to create code scanning. So for this to work, I need to build my code. So for the languages that are compilable, I need to compile my code. For others, I don't need to. So for JavaScript, I don't need to have a compile. But for C#, C++, Java, and similar, I need to have a compiler. So what I'm doing here is I have a CodeQL initiation function. Then I have a GitHub action that can auto-build this and monitor the build. In most cases, this will be sufficient. Of course, there are configuration here where I can choose to do a custom build and so on. And afterwards, what I'm doing here is doing analysis and posting this to GitHub. So let's do commit of this new action. So what I'm seeing here is I have a CodeQL action triggered. And right now, I can see that I have 2 jobs queued. So we will let this run, and while it runs, I can just mention really shortly. So this is a great tool, and the benefits here is everything is accessible, and working with security is like going to a gym. So it's not just to turn it on, you need to monitor, you need to work with it. The good thing with this is the gym is actually really accessible. It's in your home, it's on demand. So every time you need to do something, the GitHub will alert you and you will be able to act on it in the context of your work. I will get this to run, but during that time, we have possibility to go and talk a bit about. So if you have discussion, if we can have a discussion, we can have questions, and I can try to answer them as well. So let's see if there are there any questions in the chat.
No, we don't have any chat questions at the moment that we haven't answered in the chat.
All right. So if you have any, just ask them. But I will then the show result when it completes. Now this will create a database for my code, which included the flows and the structure. And I can see here, because there is no need for compiling, the JavaScript is quite quick, and I'm waiting for the C#. In my code, I have a backend and controller on the backend. In this controller, I have actually a method here that contains SQL injection problem. So I'm entering ID, which I'm then sending directly to the database. And this is, of course, this is a rookie mistake, but this is a great mistake to actually showcase, because people they usually know about SQL injection. So soon I will get an action when this completes. I will get the alert, and when alert is done, I can actually handle this as well. In the same way with other alerts, I can choose to ignore it or dismiss it, or I can actually create a commit that fixes this. So right now I have code scanning here, and I see that I have the row selected. So that's about it. Anything else from the chat?
No, nothing at the moment.
All right, I will be here for a while, so if there are any questions, please ask them. So, I'm finished with the presentation.
Thank you
Erika,
for nice presentation, Sanjin.
thank you. Thank you for attending.
Thank you, Sanjin. Guys out there, if you have any questions, drop them now. Otherwise, we are going to end this session today and let Sanjin to have his lunch, as well as Magnus. Yeah, Francesco says it was an awesome presentation. Thank you. Thank you, Francesco, and thank you, Sanjin, as well. So yeah, I don't see any questions popping up. So I want to thank both of you for this month. It's been 4 fantastic sessions, and I'm looking forward to having you back again for another GitHub series in the upcoming future. Maybe something
Erika.
after the summer. Who knows? But yeah, thank you so much. And of course, you guys watching, all the 4 sessions are going to be or are available on demand on our YouTube channel. And this will be also available on demand in about 48 hours. So you can always go back and view again. So with that said, thank you, Sanjin. Thank you, Magnus, for these 4 sessions.
Thank you, Erika.
Thank you, Erika. Bye, everyone. Bye-bye.
Bye.